So when last I left you, you were going to attempt to find the square root of 8 using the information that we just talked about in estimating square roots. Let's go with blue. So I look at the square root of 8, and I know 8 falls between 4 and 9. 8 falls between 4 and 9. So I could say, well, I know that the square root of 4 is equal to 2, and I know that the square root of 9 is equal to 3, and I'm looking for, quickly change colors, I'm looking for the square root of 8. Well, I know that's going to fall between 2 and 3 somewhere, so it's going to be approximately 2 point something. Well, 2 point what? Well, 8 is significantly closer to 9 than it is to 4. So I'd have to say that the square root of 8 is going to be closer to the square root of 9. So I could say, well, you know what, it's going to be 2.9, or approximately 2.9. You could check it on your calculator. Second function, square root 8 equals 2.82. It's actually 2.82, so I'm pretty close. But again, remember, this is just estimating, and as long as you're close on your estimate and you have some good justification on how to get there, well, then that's perfectly fine. We do the same thing with cube roots, except that with cube roots, you may not be as familiar with perfect cubes as you are with perfect squares. So here's a table of perfect cubes up to 10. You should know 8, 1, 8, 27, 64, 125, maybe, and of course you should know 10 for sure. The perfect cube of 1,000 of 10 is 1,000. Okay, so or the cube root of 1,000 is 10. So some of the ones you should know. Now again, we use this table to estimate cube roots. Now you'll see now though, and something I'll just quickly tell you, you'll see that with our cube root, we now have this 3. This 3 tells us we're looking for the cube root. If I had a 4 on my radical sign, well, I'd be looking for the 4th root. If I had a 5, I'd be looking for the 5th root. And we'll talk more about what all those roots and how we can work with them a little bit later. But you're fairly familiar with cube root and square root right now, so we'll just leave it at that. So the estimate of the cube root of 20. Well, 20 falls between 8 and 27 somewhere. And I know that the cube root of 8 is equal to 2. I know the cube root of 27 is equal to 3. I'm looking for, quick color change, the cube root of, well, 20 is going to be approximately equal to 2 point something, because it's going to fall between 2 and 3. Now 20 is closer to 27 than it is to 8, but not super close. So I would say maybe 2.6, 2.7, somewhere around there. Okay. Again, it's just an approximation. You could check this on your calculator. My calculator, I go math, I go 4, and I put in 20. Oops, that was all wrong. Math, 4, 20, 2.71. So my approximation was pretty close. Okay. What's our next example after this? You know what? Let's walk through the estimate of the cube root of 600. Cube root of 600, I know 600 is going to fall between 512 and 729, so it's going to be 8 or 9. So this is going to be somewhere between the cube root of 512, which was 8, and somewhere between the cube root of 729, which was 9. So the cube root, oops, color change to blue. The cube root of 600 is going to be somewhere between 8 and 9, so it's going to be 8 point something. And then you decide, well, 600, is it closer to 512 or is it closer to 729? It's kind of in the middle, maybe a little bit closer to 512 than 729. So I'm going to say, well, a little bit closer, but not a lot, 8.4. A little bit less than half. Okay. If I test that on my calculator, math, 4, 600, 8.43. So again, it's just an approximation, and as long as you're close, it's fine. Pause it here. We'll pick up the next page and the rest of the examples for section 4.1, 4.2. Lumping 4.1 and 4.2 together here because they're both quick little sections, and there's not a whole lot of meat to either of them. So we'll see you in a minute.